Okay, let's continue. Um, I didn't really take a break. I took the video, started upload, and kind of resumed. All right, so I guess I still need to do an intro. Where we are right now is we are looking at a whole bunch of failing tests, and they're failing because they are only stubbed out. You'll notice that they look exactly the same except for names, and the names has weird underscores in them. I probably can fix that. Yeah, I'll fix them. But the more important part is that the content, the body of each test, only differs from each other by this piece, this string, and they actually are real files that exist relative to this file. You won't see them in the Xcode project because they're not tracked there. They're tracked. I mean, these Xcode projects only exist so that I can run debuggers as well as to support Carthage. But these files exist and they're being read. You'll notice data contents of is being used, and they are being deserialized. They are JSON files and toml files, and they're being deserialized by JSON serialization and toml deserializer, which is what we're working on. And we pipe through the deserialized toml object into a function called doctor, and then we pass that and the JSON object into a function called equate. And from the assertion, you probably can infer equate returns the bool. And all these assertions are failing. That's because equate and doctor are both just placeholders. And the reason they're needed for doctor, well, should I explain this again? I guess the toml table is not capable of, I mean, it's, how should I say this? All right, these JSON files, I'll show you. So these JSON files, right? I'll just pick a random one. These JSON files, you'll notice that their values are all strings. I'll open up the corresponding key equals corresponding toml file here. You'll notice that if you know toml at all, you'll notice that the value is actually integer here. And in the expected, I mean, these are fixtures, so you can really infer the toml file is the input and the JSON file is the output. And what we're doing is, we go through each of the toml files and we convert them into JSON files and compare, and then the JSON files are there to be the expectation of the conversion. So, but the weird thing is we have an integer here, but we have a string here. So when we do the actual deserialization, the value should be obviously integer. You don't want strings when it's integer. But the output, the expectations are all in the form of string. That's what the doctor is supposed to take care of. It'll go through all the real values and convert them into string. And then you have, on one hand, the JSON object converted from the toml object. And on the other hand, well, I shouldn't say that. I should say the toml object that has all the value converted to string. On the other hand, you have the expected JSON object, and we need a way to make sure they are equivalent. So that's what the equate method is supposed to accomplish. All right, so let's start. I think we have all the background here. So let's write this doctor. I guess to specific for this function, you'll need to know that the toml deserializer. I don't need any of this anymore. By the way, this is what you're looking at here. I have both open because I use Vim. So I use Vim sometimes. So where are we? Where are we? Where are we? All right. Okay, so in toml, there's it's the primitives, or like toml, I should say, as a background, general background, is very similar to JSON in that you have tables, which in JSON is dictionary, I think, and then you have arrays. In JSON, you have arrays. The difference being date and time in the latest specification of toml are first class primitive values. So that's why we have a table here where to map from toml concepts to things that in Swift that this library will produce. So string will become a Swift string, integer will become int64, which is defined in the toml that requires to be 64-bit and signed. Float is double, boolean, bool. Arrays is going to be array, and table is going to be a dictionary with string being the key and any being the value. But what about all these data stuff, right? These JSON doesn't have first class dates, but toml does. We have a type in foundation to represent this kind of concept, but it's very weird because it's also related to calendar. You have date components, and there's all kinds of things that you need to deal with associated with it. And on the other hand, date cannot represent all the information a a toml date contains, because toml defines that their date is must conform, the date string must conform to RFC 3339, which is a protocol, which defines the date stamp, timestamp format required for internet protocols, which is a subset of the ISO 8601. Anyways, this format has things such as sub-second accuracy, where after the seconds, the number that represents second, you can say dot, and then 1, 2, 3, 4. That means the fraction dot 1, 2, 3, 4 of a second, and that kind of information is just lost if you try to convert to date, because you never know how many digits are sub-second digits are there, and what are they, date already doesn't, I think, doesn't represent that, and let alone like time interval, which is really just double. It's a double. It's a terrible thing because all the information is lost there, like the time zone and stuff. That's why I opted to use net time, types from net time, to represent these timestamps deserialized from toml, because net time is actually created to represent RFC 3339 dates. So they'll preserve all those information that I mentioned. I forgot where I was going. Anyways, we'll have to. So when you feed a toml file into toml deserializer, it will give you net time types as well. I guess that's what I'm trying to say. And wait a minute. I just noticed something weird. Why do I have this? Do I need it? Is it even used? I think this finally explains why there a huge piece of confusion from last video. All right, anyways, that's great. Actually, I'm gonna check that in. All right. So we're gonna take a deserialized in-memory toml. What would you call that? A toml object, toml table, I guess. And then we're gonna go through it and turn all of its leaves into strings. That's what we're doing. As that should be relatively simple, I think. So it's gonna be a recursive process, right? So let's do string e5. And let's take any value, and it's gonna return an any value, and we're just gonna what do I do? Well, we're gonna call it so string e5, and it's gonna take the table, and that's what we're returning really. I mean, this is a test, so this is probably okay. Okay. Whew. Okay. All right, let's write this function. If value is a string, we just return value. Okay. Can I say is? Else, if value is a bool, we'll return bool. And actually, there are a bunch of things we can say here. Is bool, value is int 64, value is double, I guess. What else? We can look at this table. So we dealt with string, float, bool. Actually, all these date time things has very good, I mean, actually exactly perfect string description. So maybe what we really should do is like else. Yeah. And just deal with, I mean, strings description is also perfect. All right. So I can just do this actually for most of things, except when it's a table or array, right? If table is value, right? If this is the case, then we're gonna go through each one and do things. So actually, we'll have to mutate this table. Doesn't matter the performance-wise anyway. So we're gonna mutate this table. We're gonna for each pair of key values, should I mutate the table here? It's a little iffy. I'll be a good citizen and don't do the naughty thing, right? Result of key should equal stringified value. I feel like you can write this with a reduce. You can write this with a reduce. Let's try that. Table.reduce. Result is going to be string any. And you say $1 reduce into $0 $1 dot key equals stringify $1 dot value, right? So we could just return this. Yeah? Huh? This is okay? Yeah, that compiled. Okay. Did some test pass? No. Okay. Oh, what if I do this? Will this cause some test to pass? Value table. Table is not a value. Oh, all right, fine. No test passed. How? You'd think some would pass because after this, well, we'll see. Array equals value as an array of some sort. Fuck. It's gonna be pretty similar. Array. It's gonna be an array here. So instead of doing that, you do this, and you say this guy just append the stringified value. I guess you wouldn't say value anymore, you just say $1. Well, great compiler hint. All right, of course nothing will pass because this is false all the time. But this seems like what we needed for the first step, and I'd like to test it. Right? Let's see. Let's find some interesting ones. Uh, what was the random one we were looking at earlier? Ah, okay. Let's look at no space equals no space equals no space. This guy. So let's dump out doctored table. Let's look at it. Uh-huh. Uh-huh. Its value now is a string, right? That looks great. We'll take another look. Key special chars or cars. Its value is 1, so we should expect that to be 1. I mean, there really isn't no reason to, there really isn't reason to doubt that will be different from the last example. Key numeric. These are some key tests. So we'll take a look. Doctored. Yep, that works. Something with a lot of stuff, different kind of stuff, would boost my confidence more. Something with date, maybe. Date, time, time zone. Date, time. Local date, time. Yeah, let's look at this one. Dump this baby. Milliseconds. Bye, blah, blah, blah. Okay, great. Great. Yeah, the problem with comparing string, by the way, eventually we'll run into this problem with our doubles or floats, because when you convert, inevitably the accuracy will be down, and then you're fucked. Maybe we should handle that separately. Float, long float. Let's look at this one. This will have some interesting stuff in here. Dump. This is actually not that interesting. Float, underscored float. No. Really? That's a very precise thingy. Underscored float. So the input is 9 dash blah 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 underscored float. The expected value is this. So that's actually really good. Okay. All right. Anyways, let's consider that a success. Now we're going to write the next step, which is, again, we have now theoretically two dictionary objects that are expected to be identical. Now we're going to compare them. right? Okay. And we don't know their shape. We don't have the schema for them, right? So let's just say eventually everybody will succeed. Boom, everybody just succeeds like that. Oh. Interesting. This test failed regardless. So something must be wrong in the setup of it. So, oh, serialization fail. I like that. Should I look at that right now? Nope. Don't look at it right now. Okay. All right. Let's return false to ensure we don't accidentally make some test succeed. So this is going to be very similar to this function because we're going to go through A and B, right? And if they're dictionary, we're going to go through each key and compare that for each value matched with the key, they are equivalent. And if any of them aren't, we'll return false. Yeah, and if they're array, then we'll do the same thing, go through each value in order, and they will be equated. And otherwise, they will just have to be equatable. I mean, equivalent. As simple as that. All right, all right, all right, all right, all right. All right. For A pair, B pair, in zip A and B, something like this. Gonna do this. All right, so A pair should have a key and value, right? Wait, what am I doing? This doesn't work. This won't work. All right. So for key V in A, if can I also say key V like this? If B, if guard let B V equals A K, else return false. I can't edit in with not vim for extended time because it's just too slow. All right. So we have BV, we have K. We know K should be the same. Now we just return self dot equate V and BV. Actually, it's more like if this is not the same, return false. If it's true, then we're going to go through the next one. Yeah. B is never used. What? Thanks, compiler. You found my bug. Okay. B is used now. Please acknowledge. Hello? All right. So now they could be any. If there are any, then similarly you do first do a sanity check. And then you can go through each A and B and compare. So now we can do our zip. So like AV, VV, in zip A and B. Now you can say if self.equate AV and BV are not true, then you can return false, right? This would take care of the array case. Else, if A is a string and B is a string, we return A equals B, else return false. So really now what? What is this? Why do you want case here? It's not like A is already a string, is it? I mean, I'm doing binding to, oh, oops, I think I launched Final Cut Pro by accident. Okay. All right. So I think this gets us pretty close to where we need to be. Oh. I guess if you're an array, then eventually you need to say everything is okay. Similarly for this. How about now? Can we get some passing tests? Ooh. Looky. This is beautiful. And since we took care of all the branches, Swift kindly told us we don't need this anymore, which is awesome. Yeah, I think we did what we wanted to do. Because look at this. Now we have failures, test failures that we can say why you say they're different, right? This also validates the design decision we did in the last stream where we said, should we do one big test and just go through this pass and do all the things, or should we break them up even though we went through pain to do that? The conclusion was break them up in case something fails. If something fails, we can run them individually, and it's very clear which one is broken and where should we start, where the investigation should start. Now we're already, making ways. Let's see. The doctored toml table looks like this. Milliseconds, blah. Best day ever, blah. Num offset, blah. What? Why? Okay. The JSON object. Yeah, this is the problem, as I suspected. Yeah, toml deserialization should never produce things like this. Having a offset. What? Num offset, right? Num offset. Oh, I see. I know the bug. All right. Before we dive into the bug fix, we need to declare success. Set up, add helpers to make tests to legit to make tests run for real. All right. Okay, let me check OBS real quick. $37. We can do some bug fixes. Yeah. All right. So the bug here, if you will follow, num offset has a negative 500 thingy, and this guy does not. I also think. Let me check the toml file as well. Date time dot toml. Yeah, so okay, so milliseconds. Let's look at milliseconds. Wait, what? Milliseconds here. 1977, 12, 21, 10, 32. No, 12, 21, 10, 32. 555 plus 7. Yeah, that's the exact input. And here, they converted the date. So this test I consider illegitimate. So let me explain what I'm saying. So the input, the toml input is 1977, December 21st, 10 o'clock, 32 minutes in, 0.555 seconds, and plus 7 hour from UTC. And that is what our doctored toml table output exactly is. So this is exactly like this, where the expected date is a UTC time, you'll see there's no offset from UTC, and they actually converted the hours. So they did whatever they need to do. Actually, I think you're supposed to always divide. I mean, always minus the number of differences. So 10 becomes 3. All right. So I don't think there's a bug for me for this case. And I am going to say you are wrong, datetime.json. You should do the clever thing and show me the original data. This is so the whoever wrote the test case used a destructive method to represent the date in memory. And when you spit out the date, the original time zone is gone. So you lost some information. That's why it's destructive. All right. But I suspect after this change, this test will still fail because there are 2 failures really. Let's dump this. Let's dump that. Right. So we fix this value in the JSON file. ZZZ number 5545. Okay. The input have 3 UTC. Wait, this is the JSON. This is toxic. Okay. Yeah, again, I don't think we are at fault here because they did the same thing for another value where the -5 time zone get converted into, this is called num offset, right? Num offset. This date is being converted into UTC. So they lost the time zone information. So we are actually doing better than the test case, right? I'm really kind of proud of that, actually. Num offset. This is the true value of that. Actually, why don't I just copy this, right? Yeah, this test suite is not great. Num offset. All right, now this test will pass because it should. It was wrong. Now it is correct. Okay. Now let's check that change in because it's getting wild here. The creator of the fixture expected a what do you do to an offset when you convert it into UTC? You don't convert the offset itself. You convert where the date is converted to UTC and times therefore this our implementation actually Okay, interesting. Test exponent part float. Okay, this is float. So as I mentioned earlier, this could be one of those things where precision is screwing us. All right, let's look at it. In our table, toml table and JSON table, we have minus tenth, million. What? Okay. Exponent part float. Yeah, we're not wrong. The test is wrong. Like if you expect this JSON value to be this and this, then these values should have been integers. So to have 0.0 actually is better because, like, say if you deserialize your value. Yeah, I don't know how they represent these numbers in memory, but at least from this JSON product, you cannot tell anymore that these values used to be float. So I think I'm not wrong. Part float. The test is wrong. All right. So now this test will pass, which is awesome. Our implementation is pretty good. Float underscore. What could be wrong here? Aha. Aha. So this is interesting. They expect this to be that. That's coincidental because I bet that's equal that, right? I didn't count the zeros, but why wouldn't it be? Hold on. What? This is 3E14. It's gonna be. Yeah? Okay, it's true. Alright. Alright, so we're not wrong. We're not wrong. We're just pointing things out. Similarly, I think that's the only thing that's different here. It's like this is just a style choice. This is the same information. This is a style choice. You know, you do you. You're like, you know, if it's beyond a certain number of zeros, I'm gonna do it this way. I'm like, wait a minute. Float underscore. The point is the process of deserialization is correct, right? The serialization is like, it doesn't matter. Like you get the right information in memory. That's the important part. Wait, did I not save? I saved. So there's another error in here that I didn't see. Show me. Oh, what? Oh, I fucked up. Float underscore JSON. This is the mistake. This is where the mistake is. Yeah, so really what's responsible for this formatting is the description implementation in Swift. It's this line. So like I it's not even my fault if it doesn't look beautiful like that, right? All right, all right, all right. Where are we? Where are we? We were here. Let's stop the test and restart it. Yeah. I mean, I probably can check all those things together. This is an interesting case. Infinity and nan is all float, baby. It's all float related. Print. Infinity plus is plus infinity. Nan plus is plus nan. What? Why? Nan plus should be the same as nan, right? Infinity plus should be the same as inf. No? Sorry, brother. In Swift, they should be the same. Even though I can't verify for nan, I think nan never equals nan. Double dot nan equals plus double dot nan. I think this will be false, but that's not because they're not equal. It's because of the semantic of nan. What about infinity? This should be equal though. Yep. Let's fix them. Infinity, and none. All right. I don't know how they would distinguish between inf and positive inf in memory. Maybe the deserializer just take them as, I don't even know how that works. Yeah, how would you possibly do that? That's some advanced, like, beyond IEEE 754 shit. Wait, is there something else that I'm doing wrong? Come on. Okay, there is something else I'm doing wrong. Maybe it's a legit bug finally. Dump. Nan is nan. Nan is nan. Infinity is inf. Infinity is inf. Negative nan. Negative nan is negative. What? They expect negative nan to be the same as nan? What is this shit? No. Negative nan is negative nan, okay? These weird ass expectations. There we go. Man, I should just have serious doubts with the authorities because of this kind of shit. It's like, why, how, like, this is the community standard? Oh, this is the interesting part. This is the actual legit part. Okay, let's checking all this. No, I wanna, I think I mixed it all in. Does the creator of the fixture, all right, let me fix that. The creator of the fixture of these fixtures as are made some arbitrary decisions that does not necessarily produce the wrong outputs, wrong expectations, but neither is our implementation wrong. For example, for dates, date times, they expected blah 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 blah. For infinity, they have somehow expected a different representation for inf and plus inf, which are IEEE 754 equivalent, no, identical, right? For none, they somehow made negative nan a positive nan after serialization. Vomit. Please. All right. Okay, now a actual bug. Because we didn't even get to compare them, right? Let's look at it. We ran, we get the paths, we deserialize the JSON. Let's look at it. JSON data, actually, JSON data. All right, here we go. JSON object, 3 lines. Quick false jump over the lazy dog. Let's look at the actual input. Multi-line string accidental white space. What is this? Ah, trailing white spaces. Yeah. Should this be legit? I'm almost certain. Let's look. Let me show you the way. If I do if I catch the result that our serializer produces, right? Do catch let error and print it. All right. So I'm pretty sure we'll print the error that makes a lot of sense here, but maybe not. Oh, this didn't compile. Malformed escape sequencing string, right? Because you'd expect after this, in strings you can do escape sequences, and backslash and a space is not a valid sequence. It's not a valid escape sequence. So this error is actually correct. I like this better. Yeah, fuck this test. Multi-line string accidental blah. Go away. And this test, please go away. Yeah. Success. Delete wrong expectation. Wrong. A backslash should always be followed by a string, by a valid escape in basic strings. I didn't make up because basic string is a term in the toml standard. I have problem with authorities because of this kind of poop. All right. Woo! There are a lot of good stuff here. We did a lot of good work today. Let's put it up. Actually, I forgot to update the Linux tests. Update Linux test manifest. All it does is run like the Swift package manager thingy. All right. Test submit. Now we make a pull request, and I will show you the add integration test suite. I will show you the continuous integration. Obviously, we're using Travis. If we click, we're doing the checks thing because the Travis deprecated their old open source travis.org stuff. If you click into this, you'll see we're testing against various platforms, including all the Apple OSs. It's a shame still we can't test for watchOS. Not my fault. We're testing on Linux. It's actually running in a container. Actually, I can run it here as well. Docker. Wait, I need to launch Docker because I shut it down. We're testing for CocoaPods and Carthage will go beyond it for all 4 Apple platforms and make sure the final product is successfully produced. So yeah, this is the config. Incidentally, everything really is inside the make file. You saw this earlier as well, and yeah, there's some secret stuff here. Just ignore. All right. 2,000 lines. That's because we imported the test, the fixtures. Yeah, I expect this to succeed. Anyways, thanks for watching. Feels good. If things goes wrong, I'll fix them. And other than that, have a good one.